Welcome everyone. I've decided to go ahead and provide some helpful hints about some of the tasks. So we'll start with task number 1. The goal of task number 1 was to find the area of the triangle and triangle ABC. So we're looking at ABC right in here. So some of the resources that was provided for you was to remember what the formula for area of a triangle is, and the formula for area of a triangle is equal to 1/2 the base times the height. So looking at this triangle, we have to decide what the base and the height are. So how do we figure out the measures of the base and the height? The tricky part is really with this particular triangle, and so I'm going to move it around a little bit because the way that it is, there's really not a base and a height. Like this part here looks like it's the bottom. I mean, if we just went like top to bottom, this would be the bottom. Well, it can't be sitting on a point like that. So if we rotate it, we could make it look like this, where BC here, CB is the base and AC is the height. Or we could even rotate it completely upside down, where maybe AB is the base. And then the only issue with that is that there's this mystery length in here, mystery height in here, because we can't use BC as the height for that because that's not actually how tall it is off the ground or off of the base. We would need this piece in here. So that's a tricky part when we rotate it that way. And then we could keep going and having it sit like this, a little bit more straight there, where AC is the base and BC is the height. And this really only works assuming that AC and BC are the base and height, or assuming that AC and BC, like there's the base and there's the height. So we can only assume that these two are the base and the height if this is 90 degrees right here. And just from this drawing, we can't assume that. But what we're going to do first is try to figure out if that is actually 90 degrees. And if it is, then we can move on to try to figure out this length and be able to go from there. So I'm going to leave it like this, kind of slanted like that, and we'll see how we can go about figuring out if it is a right angle in there. If we need a right angle, then we need 90 degrees, which means that we need the slopes to be opposite reciprocals. Opposite reciprocals. That's what we're looking for here. Okay, we need the slopes to be opposite reciprocals. And opposite reciprocals, it's an algebra term, and that's why I kind of said in the instructions that you're going to be using your algebra and your geometry skills here. So opposite reciprocals are when the fraction, so like if we have 2/3, then the opposite reciprocal of that would be -3/2. So we flip the fraction, but we also take the opposite of it. That's what the opposite part is. So the opposite part is dealing with your plus and minus, and the reciprocal deals with flipping it, okay? So if the slope, which you guys have to remember that slope, again, so the slope letter is M, it's rise over run. You may or may not be able to count that on the diagram provided, so you're gonna have to figure out your slope. There's also a formula for slope. I'll even write that down, y2 minus y1 over x2 minus x1. The extra videos have been provided for you. Just use your resources on this, guys. I'm not going to give you the answers on here. This is just hints. So the slopes have to be opposite reciprocals. So whenever you find the first slope, let's say it happens to be like, I'm totally making this up here, like 3/5, and maybe the one's -3/5. If it starts negative, then the opposite reciprocal would be +5/3. So if you were to have the slope of one line is positive and the other one's negative, and they're flipped like this, they're reciprocals, then that means you have a 90-degree right triangle, which means you can use you can use sides AC and BC as the base and the height, whichever one you want. Doesn't matter, whichever way you look at it. Base down at the bottom, and the height would be AC, or making AC the base and then BC the height. It doesn't matter in the calculations, okay? But once you have that's 90 degrees in there, you could figure out, you would be allowed to use those measurements for the base and the height. even if the even if the slopes do end up showing that they are opposite reciprocals, which shows that it's a 90 degrees, which shows that you're allowed to use AC and BC as the base and height, you still have to figure out what the measures of those lengths are. And you're not allowed to just try to count all the little boxes in there. You want to be using the distance formula. And I did have a link for that, I think, on Canvas for you to be able to, or on the Google Doc for you to be able to use. So the distance formula, it's a square root, but it's just plugging numbers in that you guys all have the numbers too. So you take the second x value, subtract the first x value, square that, add that to the second y value minus the first y value, also squared. So you're just plugging into this formula, and I know I'm saying just, but it's true. You're subtracting your x values, squaring it. Subtract the y values, square it. Add those two numbers together, and then take the square root, and those would be the lengths that you're using for B and C. Okay, summary. In a nutshell, find the slope of each line. Are the slopes opposite reciprocals? And we're specifically looking at that AC-BC line, not really interested in AB. Number 2, use the distance formula to find the length of the base and the height of the triangle. Plug those values into the formula for area of a triangle. And you're good to go, guys. Hope this helps. Thanks.